order to have respect for time, I will have some reference to time in front of me. Welcome, everyone. My name is Dr. Nick Williams. I like Buildpacks. I'm vaguely aware that we are in the 101 Introduction to All Things audience. And since I know what we're about to talk about, I am vaguely aware that we might dip strongly away from 101 into maybe 102, possibly 201 type references. And if you've not been to university and don't know what those numbers mean, they're very funny. And so we are going to talk about Buildpacks. And at the start, we will introduce them. Having said that, and one of the reasons I think that we're not a 101 talk is that everything I'm about to talk about now isn't really for Cloud Foundry today. So that's awkward. And because they're like many things, when you know how something's built, it's very enticing to want to talk about what's coming rather than what you can use right now. So Buildpacks as we have them right now are wonderful. I'm going to give a demonstration of, if you've done CF Push, if you saw my talk yesterday, you'll see Buildpacks live in action. But when it comes to building new Buildpacks, you're more than welcome to build Buildpacks for Cloud Foundry today. We're going to call them V3 Buildpacks, V2 Buildpacks. But what I want to talk about is V3 because it's more future-proof, and the things we're going to talk about are going to benefit you for the next 5 to 10 years, whether you're with Cloud Foundry, whether you need to put apps somewhere else. But nonetheless, what we're going to talk about here will not affect your users. That's right. If you're building Buildpacks, you are no longer a user of Cloud Foundry. You are helping users. We are making things that make developers' lives better. And you might be doing multiple roles in your life, but I am talking about you as a person who is helping make developers' lives better. So whether we talk about V2 or V3, it is all for the benefit of Cloud Foundry users. So a little bit of a history of what I mean by V2 and V3, because I certainly needed clarification. When I first discovered Cloud Foundry, when it was first released in 2011, it did not have Buildpacks. But Heroku, from where Buildpacks came from, which first came out in 2005, 6, 7, they came out with this concept of Buildpacks. Heroku was originally just for deploying Ruby apps. Turns out there are other apps that need help deploying them to the internet. And so they came up with this sort of plug-and-play method of saying, well, how about we don't just hard code the magic of taking a Java app and running it? How about we put that in a public open source Git repo so anyone can curate it on our behalf and make it better for all Heroku people and subsequently all Cloud Foundry people. So Buildpacks were one way of allowing different types of applications, source code or artifacts to be run, but also a way of, even though Heroku itself is proprietary, Buildpacks were public. And also for a Cloud Foundry, even though the Cloud Foundry your users might be using might be somewhat complex to use, Buildpacks are relatively understandable, depending on how they're written. So, in the early days when Pivotal took over Cloud Foundry, one of the first things they wanted to do was add Buildpacks, so that's 2013. And then immediately we just took all of Heroku's Buildpacks. Sounds good. And then we started rewriting them. We rewrote them primarily to add offline support so that Buildpacks could be fully enclosed. Your Cloud Foundry plus Buildpacks could be put into a dark data center without any egress access to internet and keep working so that all the dependencies were local. The last couple of years, the APIs that Heroku and Cloud Foundry support sort of evolved. We now started supporting what we call supply Buildpacks. And what a supply Buildpack is, it means that yes, your application might be a Java app or a Ruby app or a Node app, but what if you also need some Debian package? Or you also need Node, even though it's a Ruby app? Can you add other dependencies into your application? And supply Buildpacks allowed us, another language for it might be multi-buildpack. We started to add a way to do multiple Buildpacks so that your application could have one Buildpack that ran the thing, but then some other Buildpacks that added some extra dependencies. And we now have, there's one for ImageMagick. So even though there's a base ImageMagick on the thing, ImageMagick 6, what if you want ImageMagick 7? Well, there's an ImageMagick 7 Buildpack. And you can just add it in there or be added to your droplet, and your application will now get ImageMagick 7. Free TDS is another one, and there's lots of other community ones. So the Heroku people and the Cloud Foundry people, specifically Pivotal at this point. Pivotal is a primary contributor. I think I have a shout out to them in a second. They met the Heroku people and vice versa and decided, you know what, things are getting complicated. We have all these sort of multi-buildpack stories we want to tell, and really we're coming to the end of life of what we can do. Let's get together and discuss V3. And V3 is not just for Cloud Foundry and Heroku, it's for everyone. So the ideas here, and once the videos come out for this conference, I gave a talk yesterday on bringing Buildpacks to Kubernetes, and I focused entirely on these V3 Buildpacks as well. So it's the idea of these Buildpacks allow us a process of building Docker images or OCIs that you could take anywhere. Once they come into Cloud Foundry, that'll all be transparent. It'll still just be CF push, but you'll start to see these outputs turning up in Cloud Foundry. If you can't wait, then you can still take the Docker image and deploy it. But I want you to be building future-proof Buildpacks. And then, and this whole new Buildpack stuff, the exciting part of it is also it's done outside of Cloud Foundry, both in terms of code, but also in terms of it's part of the CNCF rather than the CF Foundation. I personally need to acknowledge Pivotal. Someone spent $1 gazillion looking after these Buildpacks, and sometimes that money spent doesn't seem to gain appreciation. You assume they work. You assume someone will fix them. You assume they'll be updated. The moment the new version of Java comes out, OpenJDK, how quickly will that turn up in a Buildpack? All that takes time and money, and Pivotal's been doing that for 5-6 years. The new Buildpacks, there's a lot of content. Now that I'm going to show it to you, you're going to want to learn more. You might need to explain it to other people. Between Heroku and Pivotal, and to a lesser extent myself, there's a lot of videos and content from the last year or so since they started sharing this stuff. All right, let's have a quick look at what the new Buildpacks are going to look like. Since they're not in Cloud Foundry yet, we do have a way to play with them. That's very exciting. It would be a bit boring otherwise. And so let's play with them. So I have a Node app and a Java app because it would be dull if I just did one. And all we need to do really is give it a name. So we'll call it my Node app. And this is kind of like your CF push with just the staging process. It's not going to run it anywhere. It will just build that intermediate image that you would run, which I will run shortly afterwards. So I have to get rid of, why do I have notifications if I turned off? Go away, computer. I just need a clock. I don't need to be getting Slack messages. So now, some language has changed from CF push to new V3, but the idea is the same. And now just to compare, since we're on the track, the introduction track, when we do CF push, there's two parts. One is we do staging. That's where it spits out a lot of text and says, it's a Ruby app. Ta-da! And then it spits out a lot of Ruby things. Or it figures out it's a Java app, downloads all of the internet. No, that doesn't do that. You've already done that. Because you've already got the jar, you've uploaded the jar. Java's different. And the second part is it runs it. It's got that droplet, and then it will run it 2, 4, however many instances. So what we're doing here is just the staging, the building of the artifact. In this case, we're building a Docker image. So we're going through and we're saying, hey, you've given me some source code. Allow me to figure out what it is. This is one of the great things about Buildpacks is the automatic detection. So now that is a lot of Buildpacks. One notable thing we've done as we go from V2, current Cloud Foundry, where we have one Java Buildpack, we now have many Java Buildpacks. And what this means is that there's like an OpenJDK Buildpack, but there could also be an Oracle JDK Buildpack, or whichever is your favorite, whatever you're paying for in terms of JDK, you could have a Buildpack that wraps up that. Buildpacks become more of a packaging system as much as anything else. And then later on, how we run our Java app will depend on what type of Java we've got, so Spring Boot. So the runtime and the JDK is different from how we run it, and so lots of different Buildpacks, an important part of V3. My Node app is not a Java app, so they all fail. And then it succeeds discovering that it's a Node app. 2 Buildpacks for Node, Node Engine, which is going to drop on Node.js, and Yarn, which is the packaging system for finding NPM bundles. There is another one for if you don't use Yarn, but use NPM, there's another one for that. And then off it goes. Now we move on to, we've done discovery. Now we move on to building. In this case, it's downloading things from the internet, which is a valid place to pull things from. So it's picked a version of Node. How it's figured that out would be based on the Node Buildpack. Perhaps there was something in my package.json which suggested what version of Node I'm okay with. And then it moves on to setting up some environment variables that make it happy. And then it moves on to the next Buildpack. Remember, V3 Buildpacks, more than likely, you're going to be accepting multiple Buildpacks. So we don't just have one Node.js Buildpack now. We have, in this case, 2. Not just one Java Buildpack, but like 5. So reason for giving a talk on how to make Buildpacks is there will be more reasons than before to make new Buildpacks. There will be more opportunities to slide them into your environments that your users will be operating. Therefore, I want you to know how to make them. I want you to know that they can be very simple. And I want you to know that because the Cloud Foundry ones are not simple. I want to protect you. I love you. I want to protect you. You're going to think I should make a Buildpack, and I should go and look at the Cloud Foundry Cloud Native Buildpacks, which are under the Cloud Foundry GitHub org. And you might think, this is going to be easy peasy, but they're all written in Go, and it can be quite complicated. And it might be more difficult than it should when you're first learning. And I want to protect you from making terrible life choices and doing Docker files instead. All right? If you're about to make a Docker file, I want you to call me on the hotline. Dr. Nick, I'm about to make a Docker file. Please stop me. That's the equivalent of standing on a bridge looking over the abyss. All right? I will help you through this terrible time. And so today I'm going to teach you about Buildpacks and how simple they can be. And eventually, it does node yarn things of downloading packages. This is all happening inside the build system, not on my laptop, but in this case inside Docker. And then it spits out an image. Now, I asked it to be called My Node App. That by default means a Docker IO hub URL, and off it goes. Which means it is local. I didn't publish it yet, so I can run that. Now it is an app. You're probably very used to things you do in CF push being apps. They're supposed to be long-running processes that bind to things. The demo I'm going to give you later on is not that. We're going to solve the fizz buzz problem with Buildpacks, which is so stupid that it still makes me laugh. But in this case, our node app is a process, an HTTP app, and we do need to let traffic in, so let's do that. Now, just to be clear about what we did, we took some source code, we spat out a Docker image, not just that has our source code in it, but knows how to run itself. When you do CF push, it's all a bit too magical. You sometimes don't quite clear about what's going on. I made a Docker image without a Buildpack, without a Docker file. I'll say it again. I made a Docker image without a Docker file that converted source code into something that knows how to run itself, wherever good Docker images know how to be run. And you can see that it's running on port 8080. Fortunately, in my Docker run command, I let that pass through to my local machine. And so if I do curl on the right port, we're good to go. Look at that. I am, having a good time. Okay. So. Okay, you can stop. I didn't put -ti. Ah, damn it. Excellent. Go team. And there is the equivalent for the Java one, which I didn't run, and it takes forever. So the Java one would look similar. Spring, it would figure out that it's a Spring app. We want to use Tomcat. We don't want JDBC, whatever. And you might want to add additional build packs in there that do some other testing. Put some other dependencies in. Perhaps make some config files. Perhaps whatever. Okay? And if you know how to do it, then you can add value to your entire organization, not just your team. All right. Now, if you wanted to deploy these new build packs and use them in CF, you can. They're just Docker images. Cloud Foundry for many years has supported deploying Docker apps, which I get a little frustrated when I do the Cloud Foundry survey and it says, what is your favorite orchestration system for running Docker images? And Cloud Foundry's not on the goddamn list. I say goddamn, because we're in Netherlands. And we've been damning God for a long time here. Anyway, I'm not sure if that's true. So Buildpacks. Now, we are talking about V3. If you've ever built a V2 one, you'll see that it's slightly different than this, but it's just two commands. So is it weird to talk about an API being commands that are run? But this is how they work. They are executables that are run, and we call it the API. There's some arguments passed into them, which will introduce some of them. But essentially, when we do the detect phase, where we decided, is it a Java app? Is it a Node app? Is it a Go app? Is it a FizzBuzz app? Because that's coming up. That's right, FizzBuzz. We get to find out. Look at the source code or the artifact. Is it something that we can handle? And then build is where we'll inject dependencies, perhaps unpack Ruby, unpack Java, and optionally, we might set up a process for how this thing would run itself. Okay? Now, we will come back to Buildpacks because that's what we're going to be building. But when we did Cloud Foundry, we have CF push. As an operator, the way we mutate and update and collect our Buildpacks is there is a CF create Buildpack command or CF update Buildpack. And there is a global ordered list of Buildpacks. So when CF push is done, it'll go through that list in order. And what I mean by that is you can actually go to your CF as an admin and change the order so that Ruby apps get detected first and Java apps are last or whatever. So when we move away from that global system, we introduce a new first-class concept called the builder. And the builder is essentially a collection of Buildpacks in an order. So a builder is like our own little mini Cloud Foundry that just knows how to do staging. It's a collection of Buildpacks given a base OS that it knows how to work on. And so there is a Cloud Foundry one, full of the Buildpacks that the Cloud Foundry team, the pivotal group in New York, are working on. And but what's cool is that you can both add to that or just make your own. And we'll make our own because that's fun. But I will run this command for your benefit. Pack, don't need that anymore. Pack inspect. So this is like the fun bag. This is like the demonstrate how cool this is because it's got all the Buildpacks in it. This is the one I was demonstrating before when it was implicit. When I did pack build, I'd already set this as my default, and it used this builder. And you can see that it's got lots of Buildpacks, and this is the Java group. And what it means is this group will be picked if all of the non-optional ones succeed. Okay? So if the OpenJDK detect succeeds and the Java JVM application Buildpack succeed, then this group will succeed. All right. So it's vaguely interesting that you understand this right now. Back to what the Buildpack looks like is far more important. So I mentioned groups. So there's actually two node groups. Both of them have Node Engine, but one of them detects that it's a yarn application. Another one detects that it's got a package lock file. So rather than take another programming language like that, is that you wouldn't understand anyway. Well, not everyone would understand. I mean, if I picked Rust, I wouldn't understand it. So rather than rebuild an existing one like Ruby, because there is already on the buildpacks.io website, there is a walkthrough tutorial that you can go through, I highly recommend it, that builds a sort of a Ruby build pack. And so rather than just go through that, which you can do yourself, I came up with a brand new idea. And that is we're going to solve the FizzBuzz problem using Buildpacks. Now, this is obviously stupid. I apologize for its simple stupidity. Because it's not really solving the FizzBuzz. What we're going to do is we're going to take an application that has one file in it called count. So this is my source code. I'm going to convert a count file into a Docker image that runs and prints out a hard-coded value. This is stupider than you can imagine. It doesn't take a number, right, and spit out FizzBuzz based on that number. No, it's worse than that. It statically compiles a file and only ever prints out the value based on that file because it's a Buildpack and that's what it does. So we're going to take, depending on whether that count file has a 1, 3, 5, 9, 15, will generate that FizzBuzz value forever. I mean, I could push this to the internet And you could download it to your Docker, and it will print out the number, because Docker's so cool. This is what our FizzBuzz will do. And these are sort of pseudo commands, but this is so dumb. But what do we got here? Builder. All right. So I'll just do echo 15. No, I can't do it the whole. Oh, this is so stupid. Test app. So I've got a blank folder. We're just going to echo 15 into the file count. So this is my app. I'm going to run a Buildpack across this. Obviously, if I gave this the Cloud Foundry Buildpack builder, they'd all fail. None of them would succeed. All right? But we're going to make a new one. And what it will do is pack build. All right. And I've already done this work, so I just want to show you the silliness of what we're going to build and what this Buildpack looks like. But it teaches you the ideas of making a Buildpack without taking ourselves too seriously. It detected my app, it says, yes, you have a count file. I know what to do with that. And then it goes on to building, and unfortunately I don't have any output. That wasn't very clever, but it did spit out a Docker file image called Playtime, and it is runnable, and it prints out FizzBuzz. Okay, I can't believe I've spoken for so long and covered so little. I do apologize. So I'm going to show you these things, and I will produce, there's a Git repo with a lot of this content, and I will, if you ask me nicely, I will do YouTube videos. If you don't ask, I won't make them. But if one person asks, that's probably all it takes, where I'll go through this in more length, given that the 20 minutes I've spent introducing this problem doesn't allow for a lot of additional time. But here is essentially the gist of my Buildpack. I said it was 2 files, they're executables, and I've written them in shell because that's a lot more readable. So essentially, the detect says, well, does it have a count file? I feel like we should all fix things. And I don't need any of that. I just need it to return. I just need to return 0 if it succeeds or anything else if it fails. So a little bit of bash testing, is there a count file? And then the build one, the solution to my problem is really just a bunch of static files, which I'm going to show you what the contents are. But this is where you would unpack Ruby. This is where you would unpack Node. This is where you would create configuration files in this build. And this is what my files look like. I will start with the one on the right, which is my executable. Okay? This is where I solve statically. For my static count file, it will look at that count file and convert it to FizzBuzz. Since count never changes, because it's static, obviously the answer never changes, but this is my interpretation of solving the problem in shell. But what's important is that it's a runnable application. I've taken the source and I've created a runnable application. And so I'm basically creating that little file. Now this is, again, Ruby would be or Java or JDK or whatever. These are the runnable things that you might be adding with your Buildpack. Or you might be installing libraries, system libraries, or additional things on the file system. In this case, I'm installing an executable. Now, my Docker file, my Buildpack is all-inclusive. It not only installs software, this is my excuse for a piece of software. I installed this, I'm very clever. It assumes bash is on the system. But I also want my Docker image to know how to run itself. And so the way we do that is we add a launch.toml file. You know Buildpacks are good because we're not using YAML or JSON. We've moved on and we're using TOML. And for simple TOML, I can read it, but my God, it gets hard to read very quickly. Off the topic, there is a little CLI called YJ. It's written by Stephen Levine in the Buildpack team, and it's awesome. It does an M-to-M of every different YAML to TOML to JSON to, so it's a super handy tool, and often you convert TOML into JSON and then put it in JQ, and then you can understand what the hell it said. So anyway, this is TOML. So essentially, a launch.toml is where you say that there is a web process or other processes that you might want to run or tasks. And I'm saying that whenever this Docker image is run, I want display count to be run. And it's not a long-running process. It's not like it starts a web app. It just prints an answer and exits. And that's okay. That's what my Buildpack does. We're not all about making web apps here. You can do anything with Buildpacks. It doesn't have to be a web app. You can compile Java and put it in an output. Now, and then a little bit of a nuance, but then also we need to say that this layer is going to go in the final Docker image. And we won't cover any more of that here. But that's essentially what's in my Buildpack. And so you saw the output. It resolves to yes, this path has a count file in it, and then it would print out something. My little demonstration earlier did not print that out, but that's pretty good. Now, there is a Git repo that contains these examples, and I've got a README to it, and it's very walk-throughable, since that's more practical than me talking and you doing nothing. And tell me if I'm wrong, but I feel like I'm doing all the work here. So there is another example of another tiny little Buildpack, which if there's a message file, will detect it. And when you run the final image, it just prints it out. Similar but different, but you can start to see how the detects work, and you can put them together in a shared builder and give it either of those two types of source code, and it will detect and print out. So here is an example of if we just gave it the FizzBuzz one, then it would fail on our message. No, it works. No, I'm not going to track. So here, I wish I gave myself more time. I apologize. But I do agree, very clearly, I have written a very long sort of tutorial that goes with this. If you go through it and have any troubles, please let me know and I will explain anything. There is a Buildpacks Slack account, there is the Cloud Foundry Slack, and there is a Buildpacks channel in that. Primarily, that is for the Cloud Foundry Buildpacks. For the Cloud Native Buildpacks, and just general discussion around what they look like and how you'd write one, there is a Buildpack Slack, and I'll hang out there too, and we can talk about that. But the same idea for building this one is we'll have the print message toml, which says, hey, I've got a way, this is how I want to run my image if you ever run it. And then that we install some software. Here I install two little command line tools. And a new idea is that you can inject environment variables. Your Buildpack can inject changes to the environment that will always be loaded up. And that can be very helpful, either to mutate environment variables that are coming in and change them, or just to add new environment variables. You can create configuration files. There's a lot of things you can do with profile.d. And we run that. And then finally, there's the idea of the builder. This is where you get to create your own little Cloud Foundry. So instead of Cloud Foundry CF Buildpacks with all the standard Buildpacks, this is like all the things you care about in your company or your team. And you can put that together. What you'll probably find you're doing with this is you will be taking the upstream Cloud Foundry builder and mutating it and adding in the Buildpacks that you'll make. The Buildpacks are very simple, as I said. They're just detect and a build. Now, in these examples, did not, before I will finish, I just want to show you, on the flight over, I built a Buildpack for Redis, which again is silly, but the idea for the Buildpack is it will inject Redis, basically install Redis, so that you've got the Redis CLI and a Redis server. And what's interesting about that Buildpack is it's an example of how you might bring in assets, compiled or uncompiled. And it's useful to walk through. None of that toml is fun to explain. So the principle of a builder is it's a collection of Buildpacks that you give to the developers. And your applications will either pick one of the Buildpacks or the other. Cloud Foundry team is building a builder. God, I hate that sentence. The Cloud Foundry Buildpacks team are constantly curating a builder that includes all of our future Buildpacks. And you can start to use them now, and you can start to contribute to them, or you can start to write additional Buildpacks that go with that your organization will want. And then you'll be able to look at it. So this is what our builder looks like that we would have made if I had 2 hours instead of 30 minutes. Apparently, it looked a lot smaller when I wrote it down, I honestly felt like that was a good amount of content to get through in 30 minutes. But here is this idea of a FizzBuzz Buildpack and our print message Buildpack. Two separate groups. One will detect all the other. And we had and I mentioned groups before, but when we did the yarn node example, there were two Buildpacks in a group, and they both detected. So Buildpacks are coming. They've been coming for a year. The CF team are starting to figure out how they might work. There is bring them in to Cloud Foundry, but it is definitely worth investigating how they look now, how you might use them, how you might evolve what it is to build apps in your organization, how you bring dependencies in. And if you do want to build V2, and you felt like the last 30 minutes I should have been talking about V2 Buildpacks, I think you're wrong. But I have done, you're not wrong, you're perfectly valid. I've got a series of blog posts where we talk about making V2 Buildpacks based around sidecars, because I thought that might be interesting. And if you want me to point you to those, just ping me on Twitter or on Slack, and I'll find those for you. There is the URLs. These slides are already on the schedule, so you can go to the talk, and the slides are downloaded to get these URLs. Those FizzBuzz examples and the print message and a bunch of other examples are in that repo. And finally, I will quickly show you the thing that's not mentioned, which is the Redis Buildpack. Same idea. What's interesting, perhaps, is I started to explore dependencies. So Redis, in this case, before I was just making up executables and but Redis, we actually want Redis. So here is the upstream versions of Redis. Here are some compiled versions. I'm just playing around with it. And the Buildpack actually knows how to compile. So this is my exploration of how we would download and install Redis into a layer, but cache it so that it only ever gets compiled once. So Buildpacks has caching. Buildpacks has processes. The new V3 Buildpacks are really interesting, and have a play with them both through the example repos. And if you want to hang out on the Slack channel, we can talk about it there too. So thank you very much. Now, we are at 30-something minutes, so I apologize for those who have somewhere else to be, but I happily take questions. I can just keep talking. I think this topic's really interesting. Buildpacks are yes?
It looks like software versions are kind of hard-coded in the Buildpacks. What happens if I have multiple Buildpacks, but they require different versions of software? So do they clash and
You're saying, we're like with the Redis one, dun, 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 dun. Come on. You're referring to versions of software like this? So in your example, you would like, so I've written this example Buildpack to sort of say, you probably want either version 4 or version 5 of Redis. And you want the latest because you want to, CVEs and updates and things like that. If you specifically want an older version of Redis for some reason, either don't use the new Buildpack, go and find the old Buildpack over a previous, they assume I would issue multiple versions of this Buildpack over time. So I cut a version, and if a new version of Redis comes out, I would then update this TOML and then cut a new version of the Buildpack. And you would use that or not. And that would go off into builders. And so one way is just to change what version. Sorry, how do I put it? When you do apt-get install Redis, it doesn't give you an option for 7 different versions of Redis. It kind of gives you the version that's in the package. So Buildpacks are kind of like Debian packages in a way. Arguably, maybe I shouldn't have 2 versions of Redis. Maybe I should have a Redis 4 Buildpack and a Redis 5 Buildpack. And that could be another way to do it. And you pick one. I've gone with one Buildpack that supports 2 different versions, but another approach might be 2 Buildpacks for 2 major versions, and then you would have an entire tree of history of versions. Right, yeah, and that is an interesting topic, compatibility. So the question was, how do you know which Buildpacks are compatible with each other? They are all they're all write to different folders. So if you actually forced all build packs to be installed, they would all work. The final image might not do anything, but all the layers would be added. They're all mutually exclusive. They've given a folder called a layer to write to. It's called a layer, and it also represents an image layer. Whether the resulting thing can use them all, but they will all install because they're all independent. So you would be able to run this, add this build pack to any app, and you'll get Redis, whether you use it or not. All right. If you have any more questions, I'll meet you at the back. But thank you very much.